Hi everybody, I'm going to document my reactor build. As you can see here, quite a few parts. May look a little bit intimidating, a little bit confusing. I'm going to explain a little bit more about all the parts. Maybe just a little bit of history. I've been like mulling over this idea now for about 4 months. I've been following Jerry's build, the circus reactor. I knew about them before that as well. I never really thought about using a 4-inch by 20-inch long water filter. I still have a problem with them. I have mixed reactions when I hear videos, people saying there's a lack of flow or loss of flow. So I kind of have a mixed reaction about them. I'm not sure what result Jerry's getting out of it. And I'm not very fond of the Rex rig reactor, I think it's called. Again, mixed reaction from people who've used them. So I've come up with my own design, maybe a mix of the two kind of, and I'll explain it a little bit. I call it the inverted CO2 reactor because it's upside down from what people are familiar with actually. What you're looking at here is actually the bottom of the reactor. I'm going to be feeding CO2 in from the bottom. Yes, you heard right, the bottom. The main component here, the main part, this whole thing is going to be screwed right into my pump, a 9.5 mag 9.5 with fractioning impeller. This collar, this bushing right here, is a female 3/4 inch, which will sit and screw right into my pump. The whole reactor will screw right into the pump. All this will be put together. And the principle here is that I'm going to be feeding CO2 right up into the reactor. So I have this guy here, it's going to fit into there. I'll explain that a little bit later in another video. I'm going to be screwing, so now we have this. I'll be screwing the 3/4 inch PVC with a T at the end. This will all go, imagine that, all together here. You can see it pass through there. It gets put into the pipe. Do that again. So I've connected that. Goes into the pipe right here. Now imagine this guy is screwed into the top where you saw it before. Goes all the way. This is longer than what I really need right now. I haven't measured everything yet, but I'm gonna have to cut that the 4-inch PVC pipe. Let me move over a bit here now. So at the end I'm going to have a T, as you can see here. That T is going to go all the way to the end. I have a cap here. I'm going to be putting a cap. I have a collar. It's going to fit on the pipe. It's a threaded collar, you can see, with a cap. I want to be able to open this guy up and clean it. So I'm going to be able to take the cap off. And this guy, the 3/4 inch, will be threaded at the bottom as well, so I can take him out if I have to do more of a cleaning, get a good brush in there. Now what's going to happen, what I'm hoping will happen actually, this T will be fitting a little bit, I wouldn't say all the way up. It's going to be kind of in the cap, and I'm going to notch out at a 45-degree angle this side of the T and the opposite side over here. So as the CO2 comes out, the CO2 will hit the wall and diverge in this direction. Same with this one. It will come here. This will be notched out, and so we're going to get a turbulence in here going in that direction all the way down the pipe. So it's just going to churn up the CO2, mix it all up, all the way down the pipe. So CO2 comes up through my 3/4 inch pipe, out the T, comes back down the pipe, out here. Here I have, this T is actually 4-inch, 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 and over here is 3-inch. You can get them 2-inch as well. I wasn't able to get 2-inch. If I would have been able to get 2-inch, I would have got 2-inch. So I got a 3-inch reducer, 3-inch, to 1 inch. 3 inch to 1 inch. I want to go to 1 inch. You can go to whatever you want, 3/4, half, whatever. I went to 1 inch. If I want to go to 3/4, I can just use a reducer after that. That was my main reason. Now I have two options here. I can put this elbow here and do kind of like I do currently. Actually, right now I have two pumps in my sump. One is a Mag 9.5 with a fractioning impeller. CO2 is being fed into the pump, broken up, and that outlet to the pump is directed towards the Mag 1800, which picks up the CO2, a lot of bubbles, feeds them into the tank. So I want to try and get rid of the bubbles. That's what I don't like right now, and I'm hoping this reactor will do that for me. So right now what I'm going to do initially, just direct that towards the my Mag 1800. Hopefully a lot less bubbles, I'm sure it will be, and have the Mag 1800 carry the CO2 into the tank. If I don't like that, I can take him off. It's not going to be glued. Everything's going to be in the sump anyway, so I'm just going to pressure fit it in there so I can take it off if ever I need. And I can replace it with this guy, which is a threaded 1 inch. It's going to slip into there. I can put a hose barb off of there, bring it up towards the tank, maybe even tee it off to 2 3/4 inch outlets. That's pretty much it. Talk a little bit about the cap. You saw the cap over here. It's going to go on the end of the pipe, the collar, and the cap is going to fit on the end of the pipe. One of the main complaints we have, I think people with the all reactors pretty much, is oxygen and CO2 buildup at the top of the pipe. What I'm going to do, I'm going to drill a hole in the top of the cap. I'm going to put this little reducer, bushing, whatever you want to call it, into the hole, glue it in, PVC glue. That's a threaded fitting. I'm going to put a hose barb, this barb right here, into the top. And I have a little Rio, it's a Rio 800 with a fractioning impeller. There's actually a place where I can connect a silicone hose tube to it, so it'll be sucking any CO2 or oxygen that's in the top of the reactor. Be sucking it out and just dumping it back into my sump, just to keep it free of any kind of buildup of oxygen or CO2. And that's pretty much the idea. I hope it's a little bit clear.